Okay, we're looking at question number 2 on the sheet now, okay? I'm just going to have it to the side of me here so I can write out the information. Suppose a converging lens has a focal length of 10 centimeters. An object of height 1 centimeter is placed in front of the lens at 15 centimeters. Locate the resulting image. Okay, so this is number 2. So, like I did before, you always start with writing out your knowns. Known. What do we know? We know that the focal length is 10 centimeters, just like question 1. We know that object height is 1 centimeter. We know that object distance, DO, is 15 centimeters, and we are looking for di. Okay? Good. And again, like I did before, I always like to write out other information. It's converging lens. Okay? And now let's start with our formula. So 1 over F equals 1 over di plus 1 over dou. Okay? Like I did not do last time, I'm going to isolate for it first. We are looking for di. So again, we have to get rid of this on this side. So how do we get rid of it? We take it away. Whatever you do to one side, you're going to do to the other. All right, now we've got it. Now we can fill it in. So 1 over F is 1 over 10 minus 1 over 15 equals 1 over di. Okay, so now we've got to come up with a common denominator here. Off the bat, 30 comes to mind. So how do we get to 30 at the bottom of 10 when it times it by 3? Whatever you do to the bottom, you have to do the top. How do we get 15 to 30? Times it by 2. Whatever we do to the bottom, we do the top. Right? Oh, sorry. Not here. Going here. So we have 3 over 30 minus 2 over 30 equals 1 over di. Okay, so let's do this. 3 over 30 minus 2 over 30. Well, that gives us 1 over 30 equals 1 over di. Cross multiply, we end up with 30 centimeters. Sorry, there, 30 centimeters. Okay, this makes sense, okay, because it's positive, okay. Remember, di is negative for virtual images. Well, this is a real image because our image, not because of our image, because of our object distance. Look at this. Our object distance here is 15 centimeters. So we place an object behind the focal length, right? So anything behind the focal length is going to give us a real image. Remember, it's when it's in front of the focal length, between the focal length and the lens, when we get those virtual images. So our object is behind the focal length, which means we're going to get a real image, all right? This is positive. Our answer is positive, which tells us it's a real image, and it's 30 centimeters, okay? That's 30 centimeters away. So this makes sense. So if you were looking at your ray diagrams, this is how you can use the ray diagrams to tell you if this makes sense, or if this, you can use the calculations to tell you if your ray diagram makes sense. So that makes sense, okay? Object is behind the focal length, okay? And we're going to get a real image, which is a positive image, and it's 30 centimeters away, which again makes sense for if you were to do the ray diagram. Okay, so that's number 2.